Hello everyone and welcome back to a new video. This is your STEM tutor and today we will be talking about graphing quadratic functions in standard form. The equation for a standard form quadratic is ax squared plus bx plus c. Your a value represents whether you are going to stretch or compress your graph. The b value will assist you in calculating the x value of your vertex. The c value will help you to find your y-intercept, and it is a constant. More on your a value. If your a value is greater than 0 but less than 1, then your graph will have a compression. If your a value is greater than 1, then your graph will have a stretch. For your y-intercept, it will be 0, c as a constant. Let's do an example. The equation is x squared plus 2x plus 1. The a value for this equation is 1, so there is no transformations. The c value for this equation is 1, so your y-intercept will be 0, 1. To calculate your vertex, or the x value of your vertex, you will use a formula negative b over 2a. For this particular equation, it will be negative 2 over 2 times the a value, which is 1. That equation simplified is negative 2 over 2, which is also equal to negative 1. So the x value of our vertex is negative 1. Now that we have the x value of our vertex, we want to find the y value. So we will take the x value and plug it back into the equation. This equation will now be negative 1 squared plus 2 times negative 1 plus 1, which can be simplified to 1 minus 2 plus 1. This simplified further is negative 1 plus 1, or 0. Now, we know our vertex is negative 1, 0. And our y value would simply be 0. We will plot this point on our coordinate plane. Left 1 and up or down 0. Now we want to find the rest of our graph. Before, we found that our a value is 1. So we will use the method 1, 3, 5 to find the rest of our points. This method can be used for any quadratic with an a value. Now we will set up a equation 1 in parentheses 1, 3, 5. You're going to distribute the 1 to each of these numbers, and 1 times 1 is 1, 1 times 3 is 3, and so on. You will then put all of the answers over 1, since we are doing rise over run to find our points, which is similar to slope that may have been covered in Algebra 1. Then you will graph all of your points. Up 1, left 1, up 1, right 1, and from that point, up 3, right 1, and so on. You can start to see a parabola forming. Once you have 5 points, you can connect your graph and draw a line through it. Now, something important to note is you want to draw a dashed line through your point or vertex. This is called the axis of symmetry, and it is the x value of your vertex. Let's move on to a new example. This example is 1/2 x squared plus 4x plus 2. The a value in this equation is 1/2, and that is a compression. Using this a value and plugging it into the axis of symmetry formula, we get -4 over 2 times 1/2, which is also equal to -4 over 1, or just -4. We now have the x value of our vertex, and we want to find the y value. So we will plug -4 back into the original equation. 1/2 times -4 squared plus 4 times -4 plus 2. Now, this simplified is 1/2 times 16 minus 16 plus 2. This simplified further is 8 minus 16 plus 2, or -6. So our vertex is -4, -6. This will get plotted on our coordinate plane. Now that the point is plotted, we will try to find the rest of our points. Our axis of symmetry, since our x value of a vertex is -4, our axis of symmetry will also be -4. Now we are going to try to find the rest of the points. First, we are going to use the 1/2 as the a value and plug it into the 1, 3, 5 method. 1/2 times 1 is 1/2, 1/2 times 3 is 3/2, and 1/2 times 5 is 5/2. We will now put all of these values over 1 and use them to plot the rest of our points. On the screen, you can see these points slowly being plotted. As you plot the points, you may begin to see a parabola starting to form. Once you have all your points, you can draw a line through them, and your parabola